Okay, I believe we are live. Let me just share this and wait for folks to join. Also test a couple of things that you can hear me and see me and everything. Let's have a look. Okay, we're gonna study some topics from the CCIE Enterprise Blueprint. Let me just get started shortly. Just noticed some weird typo in here. Okay, let's see. Wow, technology is so difficult. All right, let's go again. All right, let's see if folks will join. Okay, so this is my eVengi lab, and I was planning to do some PGP today. So I pulled up these couple of topics from the exam blueprint. So I was gonna study the local AS, allowas-in command, and remote private AS. I should know those topics already, but unfortunately I feel like I forgot, or maybe I haven't mastered them well enough in the first place. So we're gonna try to look at those, and I'll be using free resources to study, mainly the Cisco configuration guides or the master command list, which is right here. And as you can see, I have many tabs open, so I kind of did a little bit of work beforehand. Hello. Actually, if you can hear me, let me know, or if there's any issues with the stream. This is my first time, and I'm not sure if I've set it up correctly. And anyway, my desk is sort of a mess. I have a second monitor on my right-hand side here, so if you see me looking this way, I'm watching the comments on that side while my actual lab environment is in front of me. Yeah, so I'll be looking at your comment. Hello, George. Nice to see you. Glad you could join me. All right, so let's get to PGP. And actually, I had the whole blueprint open here, so I can just quickly show you what section we're talking about. PGP is somewhere over here. Yeah, there's a bunch of topics. but the ones that I've listed are under the AS path manipulations. Okay, so from the master command list. Now one note here, by the way. So this is actually like not the full command. So if you try to look it up as is from the master command list, so if we start with local AS and then we go under L here, should be this tab, and if we try to search for local AS, you see that nothing comes up. And the reason for that is that these are actually parameters or keywords in the PGP neighbor command. So you have to go under N, which I had already done here. And I have the tabs open. So here under the neighbor command, you can see like a bunch of different options. And you see allow AS-in here, AS override, all this stuff. It's under the neighbor command. So you can see it has a lot of options. But we'll focus on those three for now. Okay, thank you, George, for letting me know that you can hear me. That's good. Is the audio quality, is the volume okay? Because my mic is kind of far. I couldn't find a good placement for it because I have like my keyboard and mouse and the drawing pad and everything here. All right. Okay, so apparently allow AS-in. I thought I said we would start with local AS, but it doesn't really matter. And by the way, I'm gonna keep the tone or the vibe of this stream very casual, and this is me studying for the topics as well as trying to share my knowledge and teach you at the same time. So if you see me go silent for some time and just like reading stuff from the screen, I'm trying to figure things out. So I'll try to explain stuff as I figure it out myself. But feel free to ask questions or, I don't know, tell me your thoughts or write stuff in the comments. I'll read them as I can. All right, thank you, George, for verifying that or confirming that the audio is clear. All right. I actually don't have anything configured on my EVNG topology yet, I don't think. I did, or nothing PGP related from what I remember. Let's have a look what we actually have here. Okay, some IP addresses. We'll use R1 and R2 for now. Okay, so this information should be accurate. I've only looked at R1 and R2 for now, but I don't think there's any PGP configured here. I've configured OSPF. Let's see. I can see only one neighbor here, so looks like R5 is maybe not configured. Or if it is, that the neighborship is not come up. Let me have a look. It doesn't matter at this point because we're probably not going to use R5. Well, we can check either way. Yeah, there's nothing here. OSPF is not even configured. So that's why it's not come up. We can close this for now. Alright, let's go back to this one. Okay, neighbor allow AS-in. Let's see. To configure provider edge routers to allow re-advertisement of all prefixes containing duplicate autonomous system numbers, use the neighbor allow-as-in command in router configuration mode. Disable the advertisement of the ASN of the PE router. Use the no form of this command. Okay, maybe I have an idea what this means, but let's look at the usage guidelines as well. I feel like this is a good section in the command reference or the configuration guides. It usually explains how this command is used. Alright, so let's see. In a hub and spoke configuration, a PE router re-advertises all prefixes containing duplicate autonomous system numbers. Use the neighbor allow-as-in command to configure 2 VRFs on each PE router to receive and re-advertise prefixes are as follows. 1 VRF instance receives prefixes with ASNs from all PE routers and then re-advertises them to neighboring PE routers. The other VRF receives prefixes with ASNs from the customer edge router and re-advertises them to all PE routers in the hub and spoke configuration. You control the number of times an ASN is advertised by specifying a number from 1 to 10. Okay. Enters the address from... This is talking about VRFs. I wonder if we can try this out on the EVangel lab without having to configure multiple VRFs. Essentially what I think this means is that it will accept PGP updates that has the local AS number in the advertisement. So if we go to the topology, let's think about this. So let's see. Let me draw something on the screen here. So I think the idea is this. So let's put R1. Let's say this is AS 65001. Kind of terrible writing. And then, no, now I lost my train of thought. Between VRFs. Okay, let me just explain what I originally thought. So let's put this completely in another AS. Let's say this one is in AS 65002. So now, let's say we advertise a BGP update in this direction from R2 to R1. And I don't know, it's come from somewhere else, like from another AS. And somehow it has this AS number, R1's AS, local AS number, 65001 in it. So this update, PGP update, that already contains the 65001 in the AS path attribute. So now what I'm thinking, or let me backtrack. So normally R1 would not accept this update because this is part of the PGP loop prevention mechanism, that if you see your own AS in the AS path, you're going to drop that update. So technically R1 should not accept this. But I guess with the allow-as-in command we can do that. Alright, let me get rid of this. This is my thinking, but I'm not sure if this is correct. Alright, let's see, there's some comments here. PGP will normally not allow the prefix if it sees its own AS path in. Yes, exactly. Exactly. So that's what I'm thinking that this command is going to overwrite. So if we use this, oh, I did not mean to do that. I need to close the pen tool. So if we use this command, it's going to override that behavior and actually allow that update. But let me think about this. I'm not sure how we would test that. So wrong thing. So yeah, if we do this allow-as-in, then it would be accepted. A little check mark there. But now I'm not actually sure how we would want to test this. I guess I could do some sort of AS path prepending or like modify the attribute with a route map. Actually, I'm so rusty right now. I'm not sure I can remember how to add a fake AS number into the update so we could test this. All right, let's close this for now. Or maybe let's just do the normal PGP configuration as I've displayed here, and then let's try to figure out how we can try to send an update from R2 to R1 that would contain R1's local AS. Okay, let's go with that. So let's do some PGP configuration. So router PGP 65001, and then neighbor, what was the number? What was the IP address? It should be 10.10.12.2. Actually, why is this all over the place? Yeah, so I'm just gonna use or configure the PGP peering using the directly connected interfaces, so we don't have to do any tricks to enable the peering or for the peering to come up. Okay, so 10.10.12.2 and remote AS. We're gonna do 65,002. Let's see, what else do we have? I see some new comments. Make R1 and R5 use the same AS number. Wait, what do you mean? Do you want me to like advertise it? If we take R5 out of the picture, R1 says 1. Can you elaborate that, how you want me to set up the scenario? If you want to share anything more in the comments, I wanted to point out a couple of things about this command just as a refresh. Oh no, now this is gonna look absolutely terrible. Let me remove this. So here are a couple of pointers. So of course, in this command, we define the local AS number, which is 65,001. Now, this is the peer address of the neighbor, R2 in this case, and this is the AS number of the peer. Now, for the PGP peer, or the relationship to form, there are some things that need to match. So if you remember, PGP uses TCP to establish that session. So now, when we send a packet to R2, or actually I should explain it the other way, because we haven't configured R2 yet. So when R2 sends a packet to R1, when we configure it, it is expecting a couple of things. So these fields must match. So the source IP address in that packet must match this IP address that we've configured in the neighbor statement, and the same is true with the AS number. So these need to be configured correctly in order for this to work. Okay, So that's just a couple of things I wanted to say. Let's delete this, put this away. Okay. So let me configure the other side. And then neighbor. Okay, let's have a look. Actually, maybe I should have started Wireshark packet capture. Let me see here. Let's have a look. Yeah, we'll do that later. We can see what's happening here. All right, we don't have to worry about that now, but once we start looking at the BGP updates and stuff, it'll be better if we have that Wireshark packet capture running. Okay, was there anything more? Explain your requirement again. What requirement are we talking about? Are you talking about the PGP peering? This one that I said about the PGP peer address and the remote AS number? I think there's a few seconds of lag, by the way, so if it seems like I don't see the comments right away, or if my answer is really delayed, that's probably why. Okay, but let me try a couple of things here. Trying to remember what to do with the route map. Okay, set. What do we want to do? Oh, AS path. I guess we can do it here. I'm using the wrong keyboard layout, so that's why I keep hitting all the wrong keys. Prepend. Okay, I guess here we could do all kinds of fun stuff. So prepend last AS. Okay, I'm just gonna add R1's AS number here for now. Okay, show route map. Is that how we do it though? I need to refresh my own memory. I don't remember exactly how to configure this. Let me see. No. Yeah, okay, we can attach the route map from here. Okay, okay. I think I have an idea how to do this. Alright, but first we need to advertise something to PGP. We haven't advertised anything yet. What wants to... oh, you want to know what I want to achieve with the lab? Yeah, so I was studying these, where's my list? Here, these commands from the CCIE Enterprise Infrastructure lab exam blueprint. So local AS, allow AS-in, and remove private AS. And we started with the allow AS-in, and I was just reading through the command reference here to try to figure out what that means. So now I'm trying to set up a lab scenario where I can test how this works. So that's what we're doing right now. Yes, so let me go back to the topology right now. Let me see, what can we advertise here? We could advertise the loopback address right here. Let's see. Show and actually show yeah, okay, so this is a /32 mask. I'm thinking how I want to advertise this, whether I want to use a network command or redistribution or what. I think I might just do a network command. So show IP route. Oh yeah, or actually I have OSPF configured here as well. Technically we could redistribute OSPF routes, but I don't know if I want this to get too complicated. I'm thinking how much I want to configure and how complicated do I want this to get. So it's learning these loopback addresses via OSPF. And then these other networks as well. Hold on. Okay, what I could try to do maybe. So maybe if I advertise this loopback interface and then this directly connected network into PGP, and then we can actually change the route map so we only modify the AS path in the loopback network. So then we can see more clearly whether it's when it is dropped and when it is allowed. So if we test it first normally, so it should be dropped, and then if we add the allow AS-in command, then it should be accepted. Is that too complicated? All right, let's have a look here. Let's first try to advertise that. So yeah, because we can't really filter routes or advertise them until something is configured here. So network, let's see, mask. This needs to be an exact match, by the way. All right, let's see if we're getting anything on R1. All right, so that route is learned. Let me see from the other. Let's try the directly connected network, for example. So that was 10.10.23.0/24. let's have a look. Okay, so we're learning both routes via PGP. And actually, we can look at the packet capture as well. Where do I have it? Maybe filter it for PGP. Actually, I should know more of PGP. I was hoping if you could filter it maybe so we could only see the updates and not the keep alives. Let's have a look here. Okay, so here you can see the path attributes, and this is the AS path. So right now it only includes the AS number of R2, which makes sense because the route was advertised from R2. Okay, so now let's try to do some tricks here. So let me actually go back to R2 and so let's do another. Hold on, let me see. How do I want to do this? I guess we need to configure a prefix list that would match the loopback address. Then we can match that in the route map, and then we can modify the AS path attribute to include the AS number of R1, and then we'll leave the other route as is. I guess that could work. Okay. So let's backtrack. Let's collect our thoughts here maybe. Debug PGP IPv4 unicast updates. Good point. We can use a debug as well. I don't think I've often used that. Debug PGP. Unicast updates. All right, let's see. So let's collect our thoughts here. Where's my pen? So this is what we have so far. R1. This is in AS 6500 and or 65001. R2 in AS 65002. So now we have advertised 2.2.2.2/32 and then 10.23.0/24. So now what I want to do is create a prefix list that matches this route. Oh my gosh. Okay, so prefix list, I can't really use this thing. Prefix list. Okay. And then we're gonna modify. Okay, can this stop? Oh no, oh no. I do not know how to use my pen tool. You know what? I think I did the lock drawing thing. That's what's making a mess here. My apologies. Yeah. So then we're gonna modify the AS path attribute to include the AS of R1. So before we configure anything on R1, it should drop this route, or it should not accept. Yeah, it should not accept that. But once we configure the allow-as-in, yeah, that should be accepted. I guess that's the thought. Okay, well, let's try that. Let me get rid of this. Actually, before I do, let's see if there's any comments. None so far. All right, let's go ahead with this plan. Let's see where it gets us. Okay. So, I did not mean to do that. So let's do a prefix list. No, is it IP prefix list? I cannot remember this. Okay, so let's do it this way. R2 LO0. And then permit okay. Where's my correct keys? There we go. Okay, so now that should match R2's loopback address. Alright, so then we can actually create another route map. We don't need to use the one that I already configured as a test. So route map, let's give this some interesting name. Let's see, let me see, let's put like, I don't know, add AS path or something. Okay, so then we are matching that prefix list. Let's have a look here. Match IP address, prefix list, and then this one that we just created. Like that, and then set AS path and prepend. All right, let's have a look here. Let's add R2's AS a couple of times, for example, and then also R1's AS a couple of times, or once, sorry. Let's do something like that. Okay. Show route map. So this is what we configured. Let's just have a look here. Let's verify. So match IP address, and this is the prefix list. And then we're setting the AS path like this. Okay. Now, we need to go under the PGP configuration. And then we'll use the neighbor command, 10.10.12.1. And then we're attached the route map here. So let's have a look. Okay, route map. And I'm just gonna copy paste it to make sure that it's written correctly. Because I've used underscores here, but in case I accidentally type hyphens, it's not gonna work. All right, let's see what we have here. Incomplete command. Yeah, well, that makes sense because we're doing this out. Yes, out. Because we're advertising towards R1. We're sending these updates out. Okay. So let's see what happens here. Okay. I might have to refresh the PGP peering. Let's see. Yes. Okay, hold on. So clear IPPGP. You should not run this command in production, by the way. Okay, let's see what we get on this side. So the PGP peering was reset. Okay, here we're maybe seeing something interesting. Look at this. So it's receiving the route, but deleting it. And here it says it even more clearly. This is actually a decent debug command. Thank you for recommending that. So yeah, here it says, states clearly, denied, due to AS path contains our own AS. So now if we do show IPPGP, I guess we're getting nothing. Have I done something wrong here? Ah, I think I may know what the problem is. Let's see. Show route map. I think this is my problem. Yes. So, can you figure out what the issue is here? We can use clear IPPGP star soft out. Yes, I just always forget exactly what that syntax is, so I use the more brutal one. But thank you for reminding me of that. I can try that next. But before I continue with this, I'll give you a few moments to think about what the issue is here. Why this is actually good for troubleshooting. Why is this not learning anything via PGP? There are no PGP routes. And here it says that we received the loopback interface, but it was denied because it contains the AS path, the local, it contains the local AS number in the AS path attribute. All right, give me a moment. What's that PGP status? Yeah, we can look at PGP status. So basically the PGP peering is up, but it is not learning any prefixes. What's the reason? Yes, I see. There is the correct answer. Policy is not matching. But can you elaborate why? What's missing? So as a hint, the route map is the problem. Yes, this is true. We're not learning the 2.2.2.2 address because the route map is denying it. Or I should say that it includes R1's own AS number right here, which is why R1 is not accepting the update. But you see here that there's no mention of the 10.10.23.0 network. It is like the R1 is not learning it. Although we did not modify that. We only modified R2's loopback 0. Yes, we can do the show route map. I can do it from show run. Can I actually do now I can't remember where I get that character with my keyboard layout. Can I do section here? Route map. I'm not sure if it's gonna recognize this. Yeah, so here it is. I can actually delete that other one so it doesn't confuse us. So let me do this. Okay, so this is the route map that we have configured. So it's matching the IP address in prefix list. We can do that as well, show IP prefix list. I just keep hitting the wrong keys. So how do we read this? So match IP address, this prefix list. So essentially it's matching this route. And then after that, it's setting the AS path, prepending it with these values. Yes, correct. The route map is to the neighbor and it is affecting all update. That is true. All right, so I'm gonna tell you what it is. So if you remember the rule from access lists or route maps and whatnot, at the end of the list, there's an implicit deny. So we're actually not matching, or we're not allowing the other updates to be advertised. We don't need the prepend. I'm just using it to fake the AS path attribute value so we can include R1's AS number here. And I just added these just to change it, just so we can see it more clearly in the updates when we look at Wireshark packet capture. This is definitely not needed. So if I'm correct, if we change the route map, so if we do, actually, let's do it this way, 20, and let's have a look. I think that might be enough, because now it's permitting, and it's permitting everything. I could be wrong about this. Let me have a look here. I don't know what Alexa is doing. All right, you see, we've already learned this other route here. So essentially, this was the problem. I did not have another permit statement in the route map. So it was only permitting R2's loopback interface address. So that was only advertised to R1, but then that was denied because the AS path contains our own AS. Okay, so now everything should be good. So now our next test is to see whether that command works the way that we thought. So now we're gonna configure allow-as-in on R1. And if I've understood this correctly, it should now accept that this route, even though the AS path contains its own AS number. So let's test that now. Actually, let me have a look here quickly. Where's my Wireshark? Update message. Let's see. What am I looking at here? Route refresh message. Anyway, let's test that command now. So, neighbor. So this is our 2. 10.10.12.2, and then allow AS-in right here. All right, let's have a look here. And let's see the PGP table, show IP PGP, and voila, what do you know? Now we are accepting this route. And this is the reason why I wanted to add the AS numbers a couple of times, just so we can see that it actually changed it. And that's how you can manipulate the AS path attribute. So that's how the allow AS-in command works. Maybe we need to do a recap. This was a little bit confusing. Or were you able to follow along? All right, let me see the comment. There's a couple of new ones. Yeah, okay, so actually it was just a couple of yeses there. So I like that. If you say yes, I guess you're understanding what's happening. Okay, so one more time, let me go to the topology to explain what we just done here. Because this was a bit messy, and if someone has joined the stream in the middle of everything, so this is a good summary for them as well. So, one more time. We configured it this way. So R1 in AS65001 and R2 in AS65. Oh no, I pressed this button again. No. Go away. I have like a button on this pencil that I keep accidentally pressing, and then it like locks the... So it doesn't like stop drawing. And then this happens. Lovely. Okay, I will try to hold the pen more gently, so hopefully I don't touch that. Okay. So AS65002. All right. So after we had configured this, so R1 and R2 are PGP neighbors. So then we advertised 2.2.2.2, which is R2's loopback address, loopback 0. And then we advertised the other directly connected network towards R3. These were both done with the network command. So this is the gig 0/0 interface. And then what we did is create a prefix list to match this network. Prefix list, which was then attached to a route map. And that route map modified the AS path attribute. And I added R2's AS path attribute, or AS number. Sorry, I keep messing those terms twice here, just to show that how you can modify this. That was just for no other reason. But essentially, we made the prepend look like this. So this was added twice. And then R1's AS one time at the end here. So this is the prepend, by the way. Then R2 would also add AS, its own AS number one more time at the front. So you should see R2's AS number 3 times in the update. So now, before we had configured anything on R1, this route was dropped because it included R1's own, go away, R1's own AS number right here. So it dropped that update. And the reason why we didn't see this advertised on R1 as well is because I forgot the second match statement from the route map. So I forgot the permit slash match or whatever. I have no idea why I'm typing so poorly. Match. Oh my goodness. Yeah, so then once we had that figured out, so we added the permit statement. Actually, I can show you right now when I have the pen tool here. So now this is what the route map looks like. So once we added this, everything was working as it was supposed to. And then, you know, that route was advertised. It was actually above here. So this was still when we hadn't configured anything on R1. Okay. So let me go back to the drawing. So then finally, we added allow-as-in on R1 in the neighbor command. And then R2 or R2's loopback interface was advertised as well. So let's put a check mark here. So yeah, let's remove this, and then that's the situation right now. So you can see that both routes are learned by R1. This one has the modified AS path attribute, which contains R1's local AS number, but it is still accepted because we've configured the allow-as-in command. Okay, that was a very long explanation. Any questions? Will it make any difference if we use redistribute directly connected command irrespective of using the network command? No, it should not make a difference, because redistribution means that we're bringing those routes into PGP, but then all the path manipulation or the path attribute manipulation that we performed is done after. So once those routes are redistributed into PGP, then we can modify them with the route maps as we've done in this case, and then they're advertised to the PGP peers. No questions. Okay, I hope that was clear. That was so messy. Okay, and that took a long time as well, so I guess we can move on to the next command. I hope that is going to be a little bit easier and more clear. Okay, so we can take this out. Oh yeah, this command reference kind of focused on like VRF and some kind of like MPLS environment because it talked about PE devices. We didn't do that. We just manipulated the AS path attribute to demonstrate the behavior. So obviously you wouldn't really do something like this in any realistic scenario. And probably you wouldn't see a network like this in production. This is just something that I've created to test things. And we're doing kind of ridiculous things right here. Okay, but that one is clear, so we can remove that. All right. Let's see, neighbor local AS. Let's look at that next. All right, what do we have here? To customize the AS path attribute for routes received from an ePGP neighbor, or to configure the PGP support for iPGP local AS feature, use the neighbor local AS command in address family or router configuration mode. To disable AS path attribute customization for iPGP local AS support. Okay. Let's have a look here. Usually this explanation is not very clear in my opinion. Like, I can't really tell what this command does from this description. So once again, I'm gonna scroll down a little bit to find the usage guidelines. I often find that that gives more information. So let's have a look here. Oh, this already looks fun. Caution. Let's get to that soon. Okay, so the neighbor local AS command is used to customize the AS path attribute by adding and removing autonomous system numbers for routes received from ePGP neighbors. The configuration of this command allows a router to appear to external peers as a member of another autonomous system for the purpose of autonomous system number migration. This feature simplifies the process of changing the autonomous system number in a PGP network by allowing the network operator to migrate customers to new configurations during normal service windows without disrupting existing peering arrangements. Okay, so maybe I have some kind of idea what this does. Appear to external peers as a member of another autonomous system. I think this is the key part right here, but let's read further. Let's look at the caution now. So PGP prepends the autonomous system number from each PGP network that a route traverses to maintain network reachability information and to prevent routing loops. This command should be configured only for autonomous system migration and should be deconfigured after the transition has been completed. This procedure should be attempted only by an experienced network operator. Routing loops can be created through improper configuration. Okay. Yes, I can understand why you wouldn't want to really use this command, because technically you're lying about your own AS number. Okay, let's go further. Or were there any questions? This is used for PGP confederations. I don't think this is for PGP confederation. At least it hasn't mentioned anything so far. But we'll find out. We'll find some supporting documentation if we can't figure it out from this one. So let's see. This command can be used for only true ePGP peering sessions. Well, that kind of answers the question. So it's only for true ePGP peering. So that means that rules out PGP confederations. And actually it states it even here. This command does not work for two peers in different sub-autonomous systems of a confederation. So this command supports individual peering sessions and configurations applied through peer groups or peer templates. We don't really need that information. Then there's something about the AS numbers. We're not using the 4-byte autonomous system number, so that doesn't really apply in our case either. Oh, it does say here that it is recommended to use the 4-byte AS number. To ensure a smooth transition, we recommend that all PGP speakers within an AS that is identified using a 4-byte AS number be upgraded to support 4-byte AS numbers. PGP support for iPGP local AS. That's interesting because I thought here it says it only works, or it's only used for true ePGP peering sessions, but now it mentions something about iPGP. Interesting, let's see. There can be scenarios where the network administrator wants iPGP attributes to be passed unmodified, typically to facilitate the merging of two autonomous systems. The PGP support for iPGP local AS feature causes PGP to treat an iPGP local AS connection as an iPGP connection and pass the local preference, originator ID, cluster ID, and cluster list attributes unmodified. If a PGP peer has a neighbor remote AS command and a neighbor local AS command that specify the same AS number, the session with that neighbor is treated as iPGP when advertising routes received in the session to iPGP peers that have no neighbor local AS command configured. Okay, this is something more advanced. Maybe we'll just focus on the ePGP scenario. It looks like this gets a little bit complicated. So I think I kind of understand what this means, but I'm not 100% sure. So I think, hold on. So neighbor local AS. I'm trying to figure out which way you configure this, because I think what it means. So if I go back to the topology, sorry, it's here. Let me get this pen tool again, and let's hope that I don't mess anything up this time. Were there more comments? Since we can't have two PGP AS processed on a single router and the local AS is different for different PGP peer. Yes, that is true. You can only have one AS number configured at a time. So if you need to change the AS number, then you basically need to blow up your PGP configuration. But what I think it means, so once again, so this is how we have it configured right now. AS 65001 and then AS 65002. So now let's say on R1 we want to use a different local AS number to peer with R2. But we don't want to do that because we don't want to do it the way that you would normally do, which is like no router PGP is 65001, because again it would blow up the entire PGP configuration. So I guess we can use the local AS command, local AS, and then put some other number here. What can we use? Let's say AS 65111, for example. Terrible typing again. It looks like 4 now. Oh my gosh. Okay. So I guess then, even though the real AS number is 65001, then to R2 it would appear as 65111. So that means we would need to reconfigure the neighbor statement on R2, and then we would need to add this command on R1, and technically it should work. That's how I'm thinking this command works. What are your thoughts? Correct. Okay, let's try it out. Let me remove some of this old command because we don't really need it. And let me actually... actually, let's leave it for now. So let's see what do we have here. Show run. Oh no, but I can't remember. How do I get this? Oh no, I have the wrong keyboard layout. I don't know where it is. This character. Okay, so first of all, let's remove this command. We don't need to do the AS path attribute manipulation anymore. So and I forgot to type the no. Okay. So let's just see here. Alright, so this is what we have now. And actually for the demonstration of this configuration, we don't really need those network commands either, but I'm gonna leave it just because they don't do any harm either. Okay, so let's see. And we can actually do on debug all. Or you all, we could have also typed if you want to shorten that. Okay, so we don't need this one anymore either. Let's remove that. Okay. So let me collect my thoughts again. Alright, so we want to reconfigure the ePGP peering between R1 and R2 so that R2 sees R1's AS number as 65111 instead of 65,001. But essentially we're faking this AS number because the true local AS number on R1 is going to be this. All right. So let's see. So if we do neighbor 10.10.12.2 and local AS. Yes, so 65.111. Yes, and now the PGP peering is gonna go down because right now R1 is sending the packets with the wrong AS number. So okay, that's a lot of messages, by the way. Let me see. Yeah, so here it says peer in wrong AS. So what we also need to do here. Oh no. I might want to stop this. That's too many messages. But yeah, so here we see the problem. Peer in wrong AS. So let me look at the PGP configuration again. So now R2 is expecting this AS number from R1. But because of the command that we just typed, this one, but let me look at the router configuration or the PGP configuration. So now the AS number is actually this. Or it's faking this AS number, because truly it is this configured on the router PGP command. Okay, so we need to edit this neighbor command. So let's just remove that first. And I'm not in the correct config mode, so that's not gonna work. Let's try that again. Okay, and then we reconfigure it, but modify this. So now the neighborship should come up, but we're not gonna see the log message because I just disabled logging to the console. So let's see, show IP PGP, actually summary. So there we go. So now we can see here the actual local AS number is 65,001 on R1, but then on R2 the AS number is actually showing us 65,111. That's kind of an interesting command, actually. So is that clear? Do you have any questions about that? I'll give you a few moments. I'm gonna take some more water. Okay, no questions. All right, let's move on to the next command then. Let's just see what we had here. Okay, we can close this actually. Was it remove private AS? Okay, I might need to reconfigure PGP because we've just used private PGP numbers. Let's see. Remove private AS. What did I have here? Oh, just enable remote AS command. I'm checking something. All right. So I guess this should be pretty clear from the command syntax alone. So to remove private autonomous system numbers from the autonomous system path, a list of autonomous systems that a route passes through to reach a PGP peer. In PGP outbound routing updates, use the neighbor remove private AS command in router configuration, address family configuration, or peer group template mode. Okay. Let's see usage guidelines. Is there anything interesting here? This command is available for external PGP or ePGP neighbors only. The private AS values are, and this is the range. So when an update is passed to the external neighbor, if the AS path includes private AS numbers, the software will drop the private AS numbers. It looks like maybe there's different behavior depending on the software release. So before release 15.1, okay. If the AS path includes both private and public AS numbers, the software considers this to be a configuration error and does not remove the private AS numbers. If the AS path contains the AS number of the ePGP neighbor, the private AS numbers are not removed. If this command is used with confederation, it will work as long as the private AS numbers follow the confederation portion of the AS path. And then behavior in release 15.1 and later. The neighbor remove private AS command removes private AS numbers from the AS path even if the path contains both public and private ASNs. The neighbor remove private AS command removes private AS numbers even if the AS path contains only private AS numbers. There is no likelihood of a zero-length AS path because this command can be applied to ePGP peers only, in which case the AS number of the local router is appended to the AS path. Okay. The neighbor remove private AS command removes private AS numbers even if the private ASNs appear before the configuration segments in the AS path. Okay. Upon removing private AS numbers from the AS path, the path length of prefixes being sent out will decrease. Because the AS path length is a key element of PGP path selection, it might be necessary to retain the path length. The replace AS keyword ensures that the path length is retained by replacing all removed AS numbers with the local router's AS numbers. Well, that's kind of cool as well. So if you're dropping private AS numbers from the AS path attribute, you can replace them with your local AS number. Okay, the feature can be applied to neighbors per address family. Therefore, you can apply the feature to a neighbor in one address family and not in another, affecting update messages on the outbound side of for only the address family for which the feature is configured. Okay, then there's some examples. Let's have a look at this. The following example shows a configuration that removes the private AS number from the updates sent to this neighbor. The result is that the AS path for the paths advertised by this other neighbor through AS 100 will contain only 100, as seen by autonomous system 65 or 2051. Sorry. 6500 remove. Hold on. I'm not sure I understand this. This output. This is a private AS number. Ugh, my brain is shutting down. Okay, I need to think about this. How do we want to configure this? Because now we have used the private AS numbers, so hang on, I think I still have the route map still configured here. So we can actually use this to add private AS numbers to that route. And then we can use the remove a private AS command to basically cancel this out. That's kind of funny. Yeah, that's really unnecessary. Like, you would never do that, but yeah, we could test it out that way, I guess. Another way we could do it is if we configured, for example, R3 to peer with R2 and then send some routes with private AS numbers and then see how they're advertised towards R1 with the remove private AS command. But let me see here. So is this like an outbound command? So you're using this, or you configure this on the neighbor statements that you want to send updates towards to, or like out to, if that makes sense. So I'm wondering if So let's say that we're advertising routes from R2 to R1, and we configure the remove private AS command here on the neighbor statement. So then it's like in the outbound direction. But can we also configure it in the inbound direction on R1 and then remove the AS numbers as the update comes in? No, that seems a little bit weird. I don't know. What do you think, chat? How does the remove private AS command works? I think it's in the outbound direction. Didn't it say that? Oh, and also there was that difference between the software versions. What are we running here? Show version. Where can I see it? Here it is. 15.6. I'm pretty sure this one is running the same. I think these are copies of each other, but just for the sake of it, we can check. Yes. Okay, let's see what ridiculous scenario we can come up here. Okay, this is what we have configured currently on R1. And then on R2, what do we have? Let me actually take this. So let's just take our starting point just in case here. In case we want to revert the configuration somehow. Okay. All right, so let's see what's going on. There's something going on in chat. Let me catch up. There's a couple of things here. Yeah, so you can use it only in the outbound direction. This is a feature that is used from the provider edge router to the CE router in an internet connectivity so that the private AS doesn't go into the public. Yes, that makes sense. That's what I thought as well. But actually we can still test that just for fun. That's what we're here to do, right? That's why you lab things. You can come up with ridiculous scenarios and then test how the commands work. But okay, we'll need to remove the PGP configuration, and let me just use some public AS numbers, some random ones. And then I'm gonna use that AS path attribute manipulation to add private AS numbers. But actually another problem that I'm thinking of, because we're doing it all on the same router, I'm not sure in what order it's gonna process that. Oh my lord. Okay. Okay, so let me try to collect my thoughts again. Okay, actually let's remove this one now. Okay, so what I'm planning to do and what potential problems could come up. So once again, a nice cloud here. So now let's use some random AS number, like, I don't know, 11. for example, for R1, and then let's say AS22, for example, for this one. Okay, so now what I want to do is use the route map that we had before to manipulate the AS path attribute for the loopback address, or for this loopback network here on R2. So it's going to add those private AS numbers to that update. But then I want to use the remove a private AS command on R2 to remove those private AS numbers. So you see the problem that could happen here because you're doing it all on the same router. I'm not sure if that's gonna work. So if I do that AS path manipulation, so we had that loopback 0 interface like this with the manipulated path attribute, AS path, which was like this. This was prepended like that. So, and then after this, I want to use the remove private AS command. Why can't I type? I don't know. So I'm not sure if this will happen on the same router, but we'll test it. If that doesn't work, we'll have R3 advertise some routes to R2 and then do the remove private AS command there. So that should take care of it. But let's test it. Let's see what happens. Okay. Okay. So let's completely change this. So no router PGP, or no router PGP and AS number. Okay. Let's do the same here. And we'll use 11 and 22. So now we build it again. And then neighbor. Remote AS is 22. Okay, so let's have a look here. IPBGP summary. Yes, actually we don't need any other commands here. Then let's advertise these networks again. Okay, why aren't we learning the other network? Oh no, is there a problem? Or did it just not send it yet? Network, I don't think there should be a problem. Yeah, no, it's there now. It just took a little bit to send another update, I guess. Okay, so now we're at the basic configuration. So this is before we start manipulating anything. So now they have new AS numbers. Show IP PGP, I mean summary. Here we go. Let me see here. So show route map. Okay, so I'm gonna use this route map now to add those private AS numbers to the loopback address. So to this network. Okay, but then remember now it's gonna get dropped on R1 because we don't have the allowas-in command anymore. So once the route refresh is complete and once the updates have been sent, we should only see this network on R1. Okay, let's do that. So one step at a time. So yes, terminal. Router PGP. And then neighbor 12.1. And oh, what was the syntax? Route map? Yes. Route map. And if I had been smart, I would have copied this to avoid any typing errors. And then outbound. Okay. And why did I exit out? Well, it doesn't matter. So let's give it a moment to refresh. See if we can see anything in here. Keep alives. Actually, I think I need to clear the PGP neighbors. So let's see, clear IP PGP. Where's the star? Let's try this one now, soft out. There we go, there's some update messages. Okay, here we go. Here you can actually see this, so you can see the modified AS path attribute right there. Okay, let me go to R1. So basically this one should be gone from the PGP table now. And it is still here. Why are you still here? Oh, of course. I'm silly. Because, yes, we modified the AS path attribute like this. And this was originally R1's local AS number, but of course we have changed it now. And I already forgot about that. It's 11 now. I am silly. So if we do show IP BGP summary, so here we go, the local AS number is 11. So of course, we're not using this anymore. So that's why this route is accepted right now. Which is actually good, because now we can see this modified AS path attribute right here. So this turned out well, although I explained it wrong originally, because I'm a dummy and I didn't realize that we changed the AS number. Okay, so now let's configure the remove AS or remove private AS command on R2, and then we should see that these private AS numbers have been removed. And we should only see 22 here. But once again, since we're doing this all on R2 and like we're artificially manipulating the PGP updates, I don't know how it's gonna work, like what the processing logic is, but we'll find out. So let's go here, router PGP 22, and then neighbor 10.10.12.1, and let's have a look here. The what now? Oh, yeah, it probably helps if you type this correctly. So, remove private AS. Like so. Let me see, is there any new comments? No, nothing. All right, so then we need to clear the PGP peers again. So clear IP PGP soft out, and let's see what happens. So let's do the show IP PGP again. Nothing. Yeah, so this is the thing that I was talking about, the processing logic, and I told you that it might not work. All right, let me see how do I want to modify this. Okay, so let me first talk about why I think it is not removing the private AS numbers. It's probably because that command is applied before the update manipulations happen. So let me see. Let's look at the where do I have that? This one. I'm actually gonna copy paste this on my notepad because I keep using this command, but I don't know how to get this pipe on my keyboard layout. So now what I think is happening here in the router's internal processing logic. So it probably looks at the update. And actually also, another thing I just figured. Because these, the routes that we're advertising via PGP now, they're local routes. So why would there even be any other AS numbers in the path attributes when it is generated locally? So that's another thing actually. Not just the processing logic, the order in which these commands are applied, if that makes sense. Are you following me? So like show IP, so IP PGP. So you can see here that there's actually no other AS numbers in this AS path attribute because these are locally generated routes. So then what would this command even remove? So that's actually another thing. But what I was originally considering is that like perhaps this command is applied first, or this is processed first. So you have an update, you remove the private AS numbers, but then we use the route map to manipulate the AS path attributes. So perhaps that adds the AS numbers back to the update. Does that make sense? Ugh. Oh my goodness. Okay, so I think I'm going to have to introduce R3 into this mess. But before I get to that, we could just test this for fun if this command works in the inbound direction. It shouldn't, but since we're trying things out, we could do that. So let's go to R1 and try this command. Let's see what happens. Okay, so we'll do this one. Oops. I meant to modify this first. So technically this shouldn't do anything. Can I do this actually? Do clear. I'm just gonna do a hard reset right now. Yeah, I guess that did nothing. Yeah, so we've tested that as well. This command works in the outbound direction because we know that R1 is receiving the update with these private AS numbers. So technically, if this command worked in the inbound direction as well, it should remove those. But yet here they are. So yeah, this command appears to work in the outbound direction. So we can just remove this command. That was just a quick test. Okay, so let's not mess anything up. All right, so let's see. Maybe if we apply the same configuration that we have here, the manipulation on R3, advertise R3's loop back on with the private AS path manipulation, and then have R2 remove those private AS numbers when it advertises that route to R1. I guess that's how we can test this scenario. Let me draw it on the screen here again. Let me just get a short breathing break. Let me know if you have any questions. Okay, did I have any drawings here? I did. Okay, so this did not work. What we had here. So let's modify this a little bit. So let's get rid of all of this. Okay. So let's add R3 to the scenario. So we'll have another AS here. AS33, for example. So now there's R3's loopback address. So loopback 0. So it's another /32 network. So what we're going to do, let's copy the route map from R2. So we're going to do the AS path manipulation. Yeah, it doesn't matter. I mean, we can use it as it is, or we could use even different numbers. What do you think? Is it more clear if we use the same one, or should we do it like, I don't know, like 6503? Actually, we can even put like random numbers here. 33 and 65333. Yeah, we could do something like that. That might be fun actually. So we can change it. So we can manipulate the AS path number like that. Then we'll advertise this to R2, and then we'll have R2 remove private AS. Private AS. Yeah, let's do it that way, I guess. Okay, but let's get the like template from R2. It's gonna be maybe easier that way. Let's see, show run. So we want the prefix list, this one, but we want to modify that. Let's go to Notepad. So, and then where was it? This one. This one as well. Yeah, okay. But first, maybe let's configure our Alexa wants to say something. Alexa, stop. Yeah, so let's just first configure the peering between R2 and R3. So router PGP neighbor 10.10.23.3 remote AS 33, and then we'll do the same on R3. Just checking the IP address. Yeah, it should be correct. Okay, that should do it. And actually another thing I want to check, we'll need to do this on R3 as well. So this one, let's just see here. Okay, now we have two PGP peers here, so R1 and R3. All right, so then let's do the network command. And this is 33 on our R3. It's learning this route from R2, and there's a RIB failure. Yeah, that's another thing. Let's not go there in this live stream. So let's see. Show IPPGP. Okay, so we're learning this from R3, but there's no path manipulations yet. I haven't applied that, but we're gonna do that next. So let's modify this configuration from R2. So we'll just change this to reflect the correct information on R3. So this prefix list is matching the loopback address on R3. Add AS path. This one we need to change. And then, yeah, let's modify this one a little bit. This like that. And hold on. Why did I... Well, actually, yeah, this doesn't matter. I was just looking that I forgot the second match statement again. But in this situation, it doesn't matter because we're only advertising this route anyway. So we're not advertising anything else. So technically it doesn't matter. But if I were to add another network command or route redistribution or whatever, that would not get advertised because that second permit statement is missing. But we'll just go with the flow as is right now. So there we go, and then we need to add this router PGP and neighbor 10.10.23.2. Let's copy this one and out. Okay. Now I guess I need to do the route refresh again. So clear IP PGP soft out. Okay, let's see what we got here. All right, here we go. Now R2 is receiving this route with the private AS numbers. Okay, so the next step is to configure the remove private AS command on R2. And actually, let's go on R1 as well, because it should be receiving the same route from R2. So let's have a look here. And indeed it is. Right there. So I am guessing that once we apply the remove private AS command, it's only gonna affect this one. So let's test that. On R2, router PGP 22, neighbor 10.10.12.1, and then remove private AS. Was it like that? Remove all private AS numbers. Huh. What's the difference with that? Does that move? Hold on. What did this one say? This command was modified. The all keyword and the replace AS keyword were added. Let's see. I don't know. Let's see. Let's see what happens. I am guessing that I need to do the refresh again. Hello there. We got more people on the stream. Thank you for joining us. We're just trying to figure out how to remove private AS numbers from the AS path list. Okay, let's do the route refresh. So clear IP PGP. Soft out. So let's see what happens here now. No? You don't want to remove the private AS numbers? Interesting. Did I do something wrong? And actually one more thing, I'm gonna copy this command as well. Remove private AS. Yeah, it's not removing those private AS numbers. No. Let me see what happens with this all statement. Replace AS. I'm gonna test the replace AS next, but let's see what happens with this one. Okay, that seemed to work. I wonder why didn't the previous command work? Now they're gone. Anyone have any ideas? So before we configured this command without the all parameter and it did nothing. But once we added, so this was the result on R1. So this route was still learned with the private AS numbers. But when we added the all keyword, now they have been removed. Why did it happen like that? Let me see. Maybe it was here. Let's double check the behavior. No, we have both private and public AS numbers. So it says here the neighbor remove private AS command removes private AS numbers from the AS path even if the path contains both public and private ASNs. So this is our case. So it should have removed the private AS numbers. Okay, let's see what happens with the replace. Replace AS. Let me look at this again. Okay, so let me get rid of this entirely, and then let's try the replace command. Oh, it doesn't work. So you have to do the all. Actually, I guess so. Okay. So now I guess it should add 33 like 3 times here in this AS path attributes. Because right now it's like this. Let's have a look. Oh, of course, my bad. R2 is performing this command, so R2 would of course add its own AS number, which is 22. Okay, so that works as expected, but I don't know why it didn't work without the all keyword. Okay, I don't know. Any comments on that? Chat, is anyone here? Let me see. I'm trying to collect my thoughts if I can somehow summarize what we've studied during this session. I know my brain is certainly getting tired. It's like hard to collect my thoughts and form words and make sense. Let's see here. What have I drawn here? Well, first of all, the part of that command is missing. It's remove private AS. Okay, so for some reason that command didn't work unless we added the all keyword. Although, according to the configuration, it shouldn't be required. So when we did it that way, it removed the private AS numbers that were artificially added on R3, this part that is described here. And then we did the, where should I explain this? So on R2, when we did the replace, no, sorry, remove private AS, and then we still needed the all keyword, and then replace, what was it? Replace something. I forgot already. What was the command? Replace AS. That's right. That's how well my memory works right now. Replace AS. So then what it did here is that it included its own AS number. So remove the private AS and replaced it with its own. Like so. All right, let's see. There's some comments here. The remove private AS per neighbor command forces PGP to drop the private AS numbers. Yes, correct. And it's configured for ePGP peers. When the outbound update contains a sequence of private AS numbers, the sequence is dropped. Yes, indeed, this is true. And that's exactly the behavior we saw on the routers. But interestingly, the command should have worked without the all keyword right here. But somehow it didn't. Nothing happened. We still saw the private AS numbers in the PGP update that was sent to R1. However, this could be a behavior that's specific to like the virtual version of iOS, or because this is an emulated version of iOS. So it's not the real iOS. So sometimes you can see behavior that shouldn't happen. So I don't know if this would be different on a real router. I have no way to tell or verify that right now. But at least we saw that command work with the all keyword included. And the replace AS command worked as expected as well. Yeah. So I guess that's a quick summary of what we've done. That was kind of a mess to get here. We tested out a few things, tried out a couple of commands on R2, but that didn't work. Okay, so let me remove this thing entirely and close this. So let's go back to see what we had here. So we've covered the local AS command, allow-as-in command, and the remove private AS command. Okay, so maybe let's try to summarize what each of those commands means so we can make sure that we can remember that, or we know that what we were doing during this session. So I think we did allow-as-in command first. Okay, let me see, how can I briefly try to summarize this? So let's see, so allow-as-in, so that was basically accept PGP updates. Why is this pen typing like that? That contain own AS. I think that's a good summary of that command and how it behaves. And then we had local AS. So local AS. Let's see, how can we briefly summarize that? I guess like send PGP packets from fake AS number, for the lack of a better word, or a bogus AS number. Maybe bogus would work a little bit better. So basically we tested a scenario that if your true local AS number is, for example, 65,001, then we configured the local AS number as 65111. So then to R1, this was configured on R1, and then to R2 it showed as if R1 is in the local, how can I say? So to R2 it looked like R1 was in this fake or bogus AS. So yeah, if that makes sense. I hope I explained that clearly. It's kind of hard to talk about like real local AS number and then fake or bogus local AS number. So yeah, basically to the outside world or to the ePGP peers, it's showing as another AS number than the actual real AS number, the true local AS number. Yeah, that was a little bit complicated to explain, but I hope it made sense. And then the final one, so remove private AS. And that's pretty clear from the command syntax alone. So I guess like remove private, oh my goodness, AS numbers from AS path. And as we tested this, this is in the outbound direction. And I guess ePGP peers. And that looks like cut. Out. Okay. And then there was that replace AS option as well. We can include here. Replace AS. So basically replace private AS numbers numbers with own AS. Yeah, that's about it. That's what we've covered so far in this session. Any questions? I guess there's more comments. If the AS path includes both private and public AS numbers, PGP doesn't remove the private AS numbers. This situation is considered a configuration error. If the AS path contains the AS number of the ePGP neighbor, the PGP does not remove the private AS number. Yeah, this was mentioned in the documentation. If we go back to that, I hope I didn't close it already. Yeah, so this command behaves differently depending on the software version. So yeah, here it says that it is a configuration error, as you've mentioned, and the private AS numbers are not removed. But according to the documentation, this only applies to software release version 15.1 and before. And then the behavior is different from newer software releases. But like we have no way of testing this right now because these routers are running, I believe it was 15.6. Let's double check that. Yeah, right here. So technically the behavior that we should see is this. So the AS numbers should be removed even if the path contains both public and private AS numbers. But yeah, I don't know. This is a little bit tricky. If anyone has older software release, you can test this and share your findings. But yeah, let me go back to the diagram. So this is my lovely summary of what we've discovered during this study session. So I'm gonna give you viewers a few moments if you want to ask any questions, but if not, then I'm gonna end the stream shortly. I think I've been streaming for a couple of hours now. I can't remember when I've started this, but yeah, my brain is getting overcooked and I could use a break. So yeah, let me know if you have any questions or anything else you'd like to share before I stop the live session. Yeah, we had some technical difficulties here, and especially with my drawing pad and the pen tool, I need to figure out what to do about that for next time. And also, drop a comment what you think about these live sessions, if you want more in the future, or if you prefer the regular videos that I upload. Maybe not so regularly and consistently. I should really work on that. Okay, I don't see any more comments or questions. I'm still gonna hang in here for just a few moments, but the live stream will be ending soon. Thank you to everyone who's joined and who's been watching. I really appreciate it. It's nice to have some interaction at the same time while you're trying to study something, and I got a couple of nice tips from you guys, so that's really cool. More live sessions. Okay, thank you. I will do this in the future. I was a little bit worried if this is going to be too confusing because, you know, I'm trying to figure things on my own at the same time as I'm trying to teach some topics. So yeah, it can be tricky, but I'm glad to know that it went relatively well, and maybe you enjoyed it and want to see more. Thank you very much. More positive feedback. I really appreciate it. Again, thank you for watching. All right, it seems like this is pretty clear for everyone. I don't see any questions about these topics. By the way, you can suggest other topics in the comments as well, or go on Twitter and reach out to me over there so I can have ideas for future sessions. Thank you, thank you. I really appreciate the feedback. All right, I'm gonna log off now. Let me just remove this text here. And I'm gonna end the stream. Once again, thank you very much for watching and sticking around for so long. And I'll see you next time. Bye bye.